Remaining 25 percentage of syllabus.
Okay.
We are going to discussing now in couple of class. Hardly 2 to 3 classes it can be finished. If you have any further doubts or any further things, we can you can go through it individually that faculty. Okay, right.
Okay. So can you any important questions that it's 3 blocks?
Yeah. After finishing up my end of the moment, I will give block wise important questions. Already I was given the last time only. Once again, I'll give after finishing of before finishing of my class in the last few minutes. We'll discuss like that.
Okay.
All right. If you have material, you can textbook. You can go through it, the textbook better only. Especially electronics paper, you can go through it textbook only. That's enough. This textbook, your guide, your class notebook, everything all in one. This is subject wise. This is a book only.
Okay. Only textbook questions.
Only textbook only is enough. That is more than enough for this examination point of view. For this only PG exam point of view.
Question also same.
Yeah, question also same. Maximum cases. Only few very rare cases they can pose the questions in the middle of that topics only. But 99% they can give asterisk questions only. It won't available outside this paper notes or any other test paper. So any other guides it won't available. Only university textbook only enough. That textbook only you can refer enough.
Okay.
Right. Now I'm going to starting unit number 8, block 2. Block 2, unit number 8. Keep in silent mode, everyone. That's better to listen, everyone. Don't make noise. Prasad, you can keep in silent mode.
Okay, sir.
Yeah. Block 2, unit 8. In this thing, and then the second block is based on operational amplifiers. Yeah, here also unit 8, operational amplifiers and its characteristics parameters. Unit 8 is an operational amplifier. Operational amplifier and its characteristics. Okay. The operational amplifier. First of all, what is the meaning of operational amplifier? The operational amplifier is a device. So simply, it is a device. Of amp. Simple thing is a shortcut code is a off like this. Operational amplifier is a device with differential amplifier. It can do differentiating that. It is varying. Differential amplifier at the input and a single output component. That symbol of operational amplifier like this simple thing is two inputs and one output. This is an operational amplifier. The difference in the input terminals. This is the first terminal, which is second terminal. And a single-ended output as a large differential voltage gain. Voltage gain, simplest. Here input voltage, here in, that is a difference in 1 and 2, that is a V in, which is a V out. A ratio of output voltage to input voltage, that is called as a voltage gain. If in case of power, output power by input power, that is a power gain. Generally, gain means output value by input value, simplest. Output value by input value. This gain is between the differential input and the output of the operational amplifier. Okay. In this thing is, the common mode gain will be present in that situations. That is AV is equal to V out by V in. Here V in is a difference between first and second terminals. For example, I'm taking V in is equal to high voltage is connected to V2. This is a V1. Difference between V1 and V2 or V2 and V1. That is the thing is V in nothing but is different voltage. That is a VD is equal to V2 minus V1. Differential. Yeah. And here the thing is V2 is output voltage equal to, from this value you can substitute here. Voltage gain AV is equal to V0 by V in. V in nothing but here VD. That VD is nothing but V2 minus V1. AV is equal to V0 by V2 minus V1. From that you can calculate output voltage. V out is equal to voltage gain into difference of input voltage. That is the thing. This is the value of this.
Sir, that is
If in,
V alpha, sir.
Sorry?
V alpha is equal to V2 minus V1. No?
What is alpha here?
V alpha you wrote in box, no, sir. V alpha, sir, it is.
No. It is output voltage is equal to voltage gain into voltage input voltage difference.
No, above, sir, above.
AV is equal to, this is a VD or difference. VD
Difference.
is equal to V2 minus V1. Nothing but
Okay.
is the input voltage.
Okay.
This is the output voltage. This is the value. From that. Okay. Next here, operational amplifier classified into two types. One is inverting operational amplifier. Other one is non-inverting operational amplifier. Inverting and non-inverting. This operational amplifier circuit symbol is like this. This is a pin IC pin number. IC pin number 746. Integrated circuit pin number 741. IC pin number. It contains 2 input and 1 output. Same like logic gate type only. Yeah, output is connected to here, V out, that is thing. When one is a positive, one is a negative, no? When positive terminal connected to ground, that is thing is a inverting. This positive connected to ground. This is a inverting. Inverting operational amplifier. Same thing in that diagram. Negative terminal connected to ground. Negative terminal connected to ground. This is a ground. G indicates simpleton the ground. This is a non-inverting pin. Non-inverting operational amplifier. Inverting amplifier, non-inverting operational amplifier. Yeah. Now we have to discuss in this thing. Operational amplifier used as a feedback. Here, operational amplifier using the feedback conditions. Again, there are feedbacks, two kinds. One is a positive feedback, other one is a negative feedback. Yeah, simple thing is a feedback indicates output values giving to the connection to in. That is a feedback. Feed giving to the back. That is called as a feedback. Again here, positive feedback in that condition phase with the input with 180 degrees. In that negative feedback, the anti-phase, nothing but out of phase. In positive feedback, phase with the input. In negative feedback, phase without, nothing but that is a anti-phase that is connected to input. That is called as a negative feedback operational amplifier. With phase, that is a positive feedback operational amplifier. If in case of using inverting pin, that is a inverting feedback amplifier, that is the non-inverting, that nothing. So simply you can remember inverting means positive terminal connected to ground, negative terminal connected to ground, that is a non-inverting. So in that I'm going to use explaining operational amplifier used as a feedback with inverting pin or inverting operational amplifier. So in that, first we'll discuss the diagram, then you can find out the equations. Negative terminal, positive terminal, operational amplifier A. Okay. And the thing is here, inverting pin, this is connected to ground. G. Next, third one. Negative terminal. So here input resistance, there's a R in, and a feedback resistance here connected to output. Yeah. And the one other terminal we can take here somewhere ground connection. Between these two terminals, we'll take the output V out, like the output term. So here feedback resistance RF, current is IF, feedback current IF. Voltage between these two terminals, that is a varying voltage VS. This terminal is a S terminal. Input resistance R, input current I or I in. This is again input voltage. That input voltage is here nothing but VS. So here between these two terminals, that is a VI. Between these terminal, V out. Input voltage, output voltage. Okay. Right. According to Kirchhoff law, Kirchhoff first law. You know Kirchhoff first law, at any junction, sum of current entering to the junction equals sum of current leaving to the junction. So from that you can say simply is input current at this junction, input current I in is equal to leaving to the junction. At the junction, input is equal to leaving, nothing but outputs. So from that, first we can calculate at this junction current. According to Ohm's law, V equal to IR. Then I is equal to V by R. So here V, here I current is equal to voltage difference between these two terminal. That is a VI minus VS by R in resistance. Then here VS minus V naught output. VS minus V naught by that resistance is RF. Okay. Now from this you can calculate gain, but we know voltage gain. This is a inverting now. So inverting, the positive terminal connected to ground, negative terminal is there. So that is a first you can find out voltage gain. Output voltage by input voltage. Output voltage here V out. Input is a VS. So here terminal is negative terminal, so minus V naught by VS. Okay. From that you can calculate VS value. VS is equal to something. VS is equal to minus V naught by AV. This value you can substitute here. That value you can substitute in that thing. VS value. That implies VI minus V naught. VS value. VS is equal to minus V naught by AV. So minus of minus plus V naught by AV whole divided by R in. That is equal to, instead of VS, again minus V naught by AV minus V naught whole divided by RF. From this you can find out V naught value. From that you can find out so I'm writing here just mathematical part only. From that you can calculate V naught value. V naught equal to something you will get, na? So VI plus V naught by AV equal to, you can take it common minus. So minus in that RI by RF. So better you can take, you can do this side cross multiplication. RF by RI. That implies RF by RI. RF by RI into VI plus VI, sorry, V naught by AV equal to V naught by AV plus V naught. Better you can take V naught also common. V naught into 1 by AV plus 1 or 1 plus 1 by AV, also same thing. 1 plus 1 by AV. 1 plus 1 by AV. From that you can calculate V naught value. V naught is equal to again cross multiplication. That implies V naught equal to minus RF by RI into VI plus V naught. Oh, here V naught term also there. So you won't use. So here V naught term you can send other side. Finally, we have to calculate from that equation V naught value. So here minus RF by RI into VI minus V naught into RF by RI equal to V naught into 1 plus 1 by AV. This term you can send other side. From that RF by RI into VI equal to V naught into 1 plus 1 by AV, then plus again V naught you can take common, then RF by RI. RF by RI. Okay. Cross multiplication here V naught by AV. V naught by AV. 1 second. Here V naught by, here AV also there. This AV also will be there here furtherly. Then now we can written as V naught is equal something. V naught equal to, we have to calculate V naught equal to, or else V naught into 1 plus 1 by AV plus RF by AV into RI, that is equal to minus RF by RI into VI. Okay. Yeah, this is the thing. If in case of the gain value is more, AV is more, 1 by something, 1 by 2, the smaller value, 1 by 100, that is a negligible value type. If AV is very large, then we can neglect that these terms. So compare with that value will be get larger thing only. If in case of gain is very large, we'll get only that output term. This value will be neglectable. If AV is very large, 1 by reciprocal value, that value will be very high. That is 1 by larger value will get closer to 0 only. That's why these two values negligible. Then V naught is equal to minus VI into RF plus RI, minus or else RF plus RI into VI, anything same only, minus VI into RF plus RI. This is the output voltage value. RF by RI into VI, anything will be same only. The output voltage is just the input signal value into that ratio of resistance.
Sir, what is AV, sir?
Voltage gain. AV is a voltage gain.
Voltage.
Output voltage value by input voltage value. That is called simply is a voltage gain.
Okay.
Right. Next, this is an important question only. The next furtherly in short answers, very important question, that is this thing. This is a virtual ground. This S indicates simply is a virtual ground. That point they can pose in the short answer question, means 5 marker questions. virtual ground. The branch in this thing only. Next is there in your material page number 137. Virtual ground. They can ask what is virtual ground? Explain. Just 5 marker things. The branch point, yes. The branch point, yes. But this alphabet letter is yes. Has a special significance in the operational amplifier. This S is a special signifier in operational amplifier. This may be explained by the determining the effective impedance. I think you know impedance. Already we discussed in the previous blogs. Simply is a opposition of combination of opposition of resistor values. Nothing but impedance. If in case of capacitor, resistor, inductor, these three components are there. That three components opposes resistance value. That is called as a impedance. Here, reactance impedance, capacitance impedance, reactance of capacitor, reactance of inductor, reactance of resistor. It will be different. That three component opposing resistance value will be different. That combination of that components is called a simple thing is a impedance. Here impedance nothing but one type of resistance. But one component it can oppose something. Two component combination here impedance. Impedance between the S and the ground. That S value and the ground connections between the two terminals. That sentence is important. That is given by, according to Ohm's law, V equal to IR, R is equal to V by I. Here impedance denoted with a letter of Z. Instead of R, you can use letter Z. That is Z indicates here impedance. Impedance. Yeah. Oh, from this diagram only. I raised the diagram. No? From the diagram only, you can calculate input resistance. That is nothing but a impedance. So in the previous condition thing is V from Ohm's law V equal to IR. I nothing but here Z. So Z is equal to V by I. Here which V input voltage, that is a at terminal point S na. The voltage between the S and the ground. Ground obviously zero only. Vs minus V0, that is a Vs only. Which current? Input current. That is a I in. Okay. Now we can take it as Z is equal to Vs nothing but that voltage across the feedback resistance. V equal to IR na. So from that you can take it as in terms of resistance also. Okay. Vs as it is Vs only. Input current. Input current nothing but here voltage difference between the Vs minus V not nothing but here ground, not output. That is V naught ground value equal to I in into input resistance. I in into input resistance. If you take it as across the output value, that is a Vs minus, better you can take this is a Vg. Here V naught equal to current value. That current value will get here. That is thing is IF into RF. IF into RF. That feedback current is equal to if I in is equal to IF, same current flowing through the junction, then we can consider as Vs minus V naught is equal to I in into RF. From that we can calculate I in. I in is equal to Vs minus V naught by RF. This value can substitute here instead of I in. Vs minus V naught divided by RF will go up reciprocal value. RF. Okay. Again, you can take Vs common. Then Z is equal to Vs into RF by Vs. I'm taking common. Then 1 minus V naught by Vs. This Vs get cancelled. We'll get Z is equal to RF by 1 minus V naught by Vs. This already we know V naught by Vs, nothing but output voltage by input voltage only. Here simply you can take it as gain. That is a voltage gain. AV or A, both are same meaning only. The gain symbol is a. That is the output voltage by input voltage. Output is a V naught, input is a Vs. So V naught by Vs is equal to AV, or else you can take it as A. That is the same thing only. AV is similar to A only. Then we'll get impedance. That is a RF by 1 minus A. That's it. Only this formula is enough. RF by 1 minus. If that feedback is negative feedback, then you can take minus up, minus will get plus. Obviously, we are connected, that is a inverting operation amplifier. Now, in the inverting operation amplifier, the positive terminal connected to ground, only negative terminal is connected to components. So here AV value will get is the negative. So that minus of minus will get here the AV value is will get minus V naught by Vs. The minus of minus will get plus. Sorry. That is a RF by 1 plus A. That is a Z. This is a impedance. This question is a very, very important in a examination point of view for 5 marks. Virtual ground. Is it okay? Right. Not all. Next, one more important question. That is the same page. Examination point of view. Characteristics of the ideal operational amplifier. They can ask sometime individually characteristics of ideal operational amplifier. Sometimes they can ask the differences. Ideal nothing but as a unique type. So no comparison with the other things and type. Here, that is a theory point only. Once you can refer to your material or your textbook. Material means your textbook only. Ideal operational amplifier. Ideal operational amplifier characteristics is very, very important. At least you can go through it 5 points. Input impedance is infinite. In that, already they gave the points now. Once you can go through it, the points, that answer is a very, very important examination point of view. Ideal operational amplifier, page number 137 in your textbook. First point, input impedance, nothing but input combination of resistor value, that value will be maximum. So no current. If resistance is more, if impedance is more, no current flows through it. Okay. So no current flows through the input terminals. That is the first point. That resistance value, no need to write, but just you can remember. Just you can go through it. Only left side column values only is enough in exam point of view. If you know that right side column values also, that is a different value. That is a practical operational amplifier. That range is a 10 power 6 to 10 power minus plus 3 ohm. Second point, output impedance is 0. Input impedance is, this point is important. Input impedance is infinite. Output impedance is 0. First student, they can write input impedance is 0. Output impedance is infinite. That is absolutely wrong. That correct way of ideal operation amplifier, input impedance is infinite. Output impedance is 0. Simply. The next, voltage gain is infinite. Why? Because output by input, something by infinite. That is a infinite value, not defined value. Okay. So simply remember, input impedance is infinite. Second point, output impedance is 0. Next, third point, voltage gain. Generally, voltage gain means output voltage by input voltage. Here, input voltage, that is a larger value only now. So simply you can take it as something by infinite, that is also infinite. Next one, bandwidth is infinite. Bandwidth, the width of the band is also infinite. Bandwidth also infinite. Okay. The next, output voltage is 0. Output voltage is 0. Just a second. Someone is sending message in the group class later. Is there class?
Sir, output voltage is 0 when V1 is equal to V2.
Yes.
అంటే ఇన్పుట్ ఈజ్ ఈక్వల్ టు అవుట్పుట్ అనా?
యా.
అంటే రెండు ఈక్వల్ అయినప్పుడు 0 అయిపోతుంది.
యా.
ఓకే.
షూర్. కరెక్ట్. Just a second. Yeah. Next, characteristics do not drift with the in temperature. Means you don't change with the temperatures. It can be remain constant. The characteristics do not change with the temperature. Simplest. In that 6 points, you can remember any 5 points. You can write any 5 points. You will get definitely 5 marks in examination point of view.
పక్కన ప్రాక్టికల్ ఆపరేషన్ యాంప్లిఫైర్ రాయకూడదు.
That is not compulsory. If they mention in the question, you can write. Otherwise, no need.
Okay.
If they will mention the question, you can write. Otherwise, no need.
Okay.
So in this block, one SIQ important. That is one is a virtual, especially this page only. One is a virtual ground important. Other one is a ideal operational amplifier characteristics. Out of these two, you can expect one SIQ confirmly in final exam. If in case of LAQ, that is the next point. The operational amplifier parameters and specifications. That thing is a furtherly important thing in a LAQ wise. That thing we'll see now. Just a second. Yes, operational amplifier parameters and its specifications. Here, operational amplifiers two kinds. One is inverting operational amplifier. Other one is a non-inverting operational amplifier. In that inverting, non-inverting, both the operations, few parameters are there. In that, number one is you can take any order: offset current and common mode rejection ratio. And next one is a slew rate. And these are the important things. Out of these three, you can expect 3 out of 3 or 2 compulsory in LAQ. In that, first we'll take the operational amplifier graph. Once go through it, your textbook page number 138. The theory part is given. Once you can go through along with my explanation, you can once observe textbook, it will be easy only. So that's why I'm telling page number. Page number 138, once you can see. An ideal operational amplifier gives 0 output when the input voltage is 0. Just now only we discussed now V in is equal to V out. Obviously, output voltage is 0. Above step only. An ideal operational amplifier gives 0 output when the input voltage is 0. But the practical operational amplifier 1 millivolt to 10 to the power of minus 9 nanovolt. Minus means nano. Okay, that is a practical operational amplifier. That is a different. Here, ideal operational amplifier, that is V1 is equal to V2. That is output voltage will be 0. That mechanism we can see in the graphically. After that, we'll discuss it. First, I'm taking x-axis, y-axis. On x-axis, applied voltage, nothing but V in. On y-axis, I'm taking output voltage. The graph between input voltage and output voltage. Yeah. In that, we are taking different voltages. One voltage is applied voltage is 0 condition. Other one is a negative value. Or one more thing is a positive value. When the line passing, this line indicates this line indicates 0 voltage only. Na? 0 origin. It's passing from the origin. That is a 0. This is a negative one. This is a positive one. Line A indicates 0 voltage. Line B, negative voltage. line C, that is a positive voltage. Something, but that value will be here, output value positive, something B. Same value I'm taking here, minus B. This is obviously negative, positive, positive, negative on axis scale. That thing we know. And here this voltage is a OS. The voltage terminal between the origin to this thing. It is a minus OS. In that. The voltage transfer, the curve A is of operational amplifier shown in the figure, the characteristics curve in 3 different cases. One is a A and other one is B, other one is a last one is a C. The practical amplifier, operational amplifier may take the slope of the curve, either B or C. Why? Because the practical operational amplifier voltage value between 1 millivolt to nanovolt. Nano in 10 to the power of minus 9. So 10 to the power of minus 3 to 10 to the power of minus 9. So B and C curve we can represent the practical operational amplifier things. In either case, both and B and C cases, the curve does not pass through the origin. If the curve is passed through the origin, that value here is the origin position is the voltage in and output voltage. Both the values will be 0 only at this origin position. Here, V out value negative, V in value also negative. Here, V out value positive, V in value here negative, here positive. The different. Only in the curve A condition only V in is equal to V out. That both values equivalent to 0. Remaining B and C is not equal, as not 0. Okay, that is a only A curve it can indicate the ideal operational amplifier, and B and C indicates the practical operational amplifier. Here, the voltage VOS from here to here, that voltage VOS have to be applied, that applied voltage, order to obtain minimum value is 0, maximum value certain values. That range is 10 to the power of 6 or 7 or that is the range, applied voltage range. That voltage, applied voltage is called as a effective or offset voltage. VOS is equal to input offset, OFF acid, offset voltage. Okay, that is the thing.
What is the offset voltage, sir?
That applied input voltage.
Input voltage is called offset voltage.
Yeah, simply when you are applying that input voltage between the terminal of ground and yes, that is called as simply as offset voltage.
Okay.
That is between the either inverting pin or else non-inverting pin, whatever. So you can remember here every time in inverting, non-inverting conditions. Inverting pin means positive terminal connected to ground. That is inverting. If negative terminal connected to ground, that is a non-inverting. Yeah, now I'm taking the diagram inverting operational amplifier. Inverting operational amplifier. Inverting operational amplifier means the positive terminal connected to ground, which is connected to ground. Minus to plus. Plus is connected to ground. You can take a plus here, minus below also, no issue. But here positive terminal connected to ground, that is the inverting. Here plus, here minus also okay. But every time you can take just only positive terminal is connected to ground, that is meaning is a inverting operational amplifier. If negative terminal connected to ground, that is a non-inverting operational amplifier. This negative terminal connected to input. Negative terminal connected to input condition. Here yes terminal only. This is connected to feedback resistance RF. This is connected to output. The voltage between the this terminal and other terminal automatically you can choose here one ground, I think. We'll take a voltage. Here is a V out. This is a RF. This is a R in, input resistors. That is the thing. Yeah. In that, they can mention the particularly things. First one is a offset. You have to explain about this thing detailedly. Offset operation, offset currents. Nothing but input current value, simplest. Second one is a CMRR, common mode rejection ratio. It is also important. They can mention sometime only offset currents and CMRR, common mode rejection ratio. Common mode rejection ratio. And other one, third one is a slew rate. RAT. Okay. Yes, slew rate is nothing but here that is output pulse, either in a square wave or else a sine wave, a ramp, something that is converted. That conversion purpose will use that slew rate. For example, there is a sine wave alternatingly. Sine or cos function wave is same thing only. That wave converted into maybe square like this. That wave, or maybe this wave converted into a ramp like this. That is called as a converter thing. Is simple as a slew rate. That rate is converted. This is like this. It will be there further. That is called as a simply slew rate. In exam, sometimes they can mention 3, sometimes they can mention only 2. Maybe offset current and slew rate, or maybe CMRR and offset, maybe CMRR and slew rate, or else only one. That is depending on question paper set or interest. Okay. In that one by one, we'll see from the textbook. Once you can go through it, page number 139. First one is the offset currents. In this diagram only, offset current, that is these two connected to input terminals. This is a ground, this is the input values. Okay. Once go through the textbook. Suppose we get luckily and happens to the use an operational amplifier whose input transition have the equal to VBE values. That's the base only. VB indicates is a base thing on. Then the input offset value voltage is 0. But the problem can still arise because the DC basis current, the base current of input transition are never equal to never equal, because the beta nothing but is a current gain, alpha, beta, gamma. That thing already I think you know in the transistor concept. Alpha is a current gain in common base. Beta is a current gain in common emitter. So simple thing is a current gain denoted with a letter of alpha, beta, gamma. Voltage gain dependent with the letter of A, V, or A. And next power gain denoted with the letter of AP. Resistance gain are denoted with the letter of R. Here gain all condition output by input. For current gain, it will be reflected alpha or beta or gamma. This is basic work only. For voltage gain, that is a AV. In all condition, gain means simply it's output value by input. In the voltage gain, output voltage by input voltage. Current gain, output current by input current. Similarly, power gain, for power, output power by input power, denoted with letter of AP. For resistance gain, that is a AR, output resistance by input resistance. Okay, these are terminology, basic things. Here they said is a beta, that is a current gain. B is a base input connection thing only. Okay. The two bias currents will be generally not be equal, and the difference is called offset currents. Is it clear? That thing is the main thing. That sentence is student must. Why? Because they are mentioning the question offset currents. Na? What is the offset current mean? Simplest. The two bias currents. Which two bias current? To two input terminals. Two input terminals. the two biased currents will be generally not be equal, and the difference not be equal until something difference value. That difference value is called as the different current is called as a offset current. Okay, the input offset current equal to the difference in the base current. Obviously, there are two terminals. One is a he denoted letter of VB1, IB1. Other one is a normal, that is a positive terminal thing. The different current is called as the offset current. Okay, the voltage appears at inverting input. According to Ohm's law, V equal to IR, V1 is equal to this terminal is connected to the base resistance, that is a VB. This is a base resistance RB. Sorry, this current is a IB1. It is also base A, so it will be get RB resistance value, and which is connected to some terminals. This is also connected ground type. If you want to calculate voltage across this thing, that is V1. V1 is equal to IR. V1 is equal to.
Sir, here two are connected to ground, sir.
No, this is a ground. This is a ground. This is connected to input source.
Input source, okay.
In the input source value. Okay. This is a current through this resistor is a IB1. Current through this thing is a IB2. The difference between IB1 and IB2 is called as the offset current.
Okay.
The difference between IB1 and IB2 is called as the offset current. Here, voltage across the this resistor V1 is equal to I1 into resistance value is RB. That is nothing but I1, nothing but IB1. Instead of I1, you can take it as IB1. That directly here only better. IB1. And V2 is equal to IB2 into RB. That is that thing. Voltage across these two things is called as a voltage difference. That current difference is called as a offset current. Difference in the input values. Either V1 greater than V2 or else V2 greater than V1, then you can take higher value minus least value. That is a V1 minus V2. Okay. Then,
sir, but symbolically it is showing ground, the both are.
Sorry?
Symbolically it is showing ground.
Here, that's why I written is G only. Now. This G indicates again. If you give both the inputs is ground, there's no input now.
Yes, sir. Yes, sir. Okay, sir.
Yeah, G is there, yeah, nothing is. Or else you can take simply clarification purpose, you can take the terminal connection.
Okay.
No issue. If you take here, if you feel here ground, then also no issue. One more terminal is there here. Here giving your terminal. For example, there's an origin point somewhere you are giving an input value, but here no input value is there.
Okay.
That is the meaning thing on. This is a connection whites only. Okay.
Okay.
Then we can take it as V1 minus V2. Then V1 minus V2, that is a IB1 RB minus IB2 RB. So we can take here V1 minus V2 is equal to IB1 minus IB2. This is called as a offset current. IB1 minus IB2 is called as a offset current. That's it. You have to explain the terms here. That offset current is nothing but if you take terminal here, something that is a connection. That is a IOS. Not what here ground or here yes terminals. You can use. So simply you can write this is called as a offset current. That's finished. And next one in this diagram only, second parameter is a common mode rejection ratio. CMRR. Common mode rejection ratio. That is also important thing. The input stage of operational amplifier is a differential amplifier. Differential amplifier. That is different values. One way, here two variables are there. One variable differentiating with the other thing. That is called as differential amplifier. For ideal differential amplifier, the output voltage will be proportional to the difference of input things. That is nothing but V1 variable, V1 minus V2 or V2 minus V1. When the output value, nothing but only when the two input stages are perfectly balanced. then only we'll get input value will be 0. In that condition only it can obeys the ideal operational amplifier. In the ideal operational amplifier, in the characteristics table just now only we saw now, that is a output voltage is 0 when both the input values are so input value and output value is equal. When it means if V1 is equal to V2, then only we'll get V out is equal to 0. Here V1 minus V2 is there na, that in that value V1 minus V2 is that both values are equal. Both the terminals values are same. The difference value will be get 0. In that condition only we'll get ideal operational amplifier. As a result of the imbalance, the output voltage as a non-zero voltage, even through if V1 value, V2 value same. If in case of resistance values are unequal, then we'll get some that particular resistance current value will be different. So in that conditions, a value V1, V2 is called as a common mode rejection ratio. Is it clear my point? Simply V1 is equal to V2, then V0 is equal to 0. ఇలా ఈ కూడా as a result of the imbalance, output voltage as a non-zero value, even though V1 equal to V2, that imbalance condition case a common mode rejection ratio. Just a second. Yes. Right, that is a CMRR, common mode rejection ratio. In that thing, we can find out that is a voltage, common voltage, that is a VC is equal to input voltage is the difference voltage, VD is equal to V1 minus V2. VD is equal to V1 minus V2.
Sir, 1 minute.
The differential mode input voltage.
Sir.
What?
Sir, V1 is equal to V2 అయినా సరే ఇంబ్యాలెన్స్ గా ఉంటుందని చెప్తున్నారండి.
Yes. Yes.
Okay.
That imbalance condition common mode rejection ratio thing.
Okay, sir. Even though equal ga uన్నా sir.
Yes. That common mode input value is called as a imbalance ga unnappudu that condition value is that is VC, that is equal to V1 plus V2 by 2. Imbalance ga unnappudu na voltage. Common mode input voltage when if the imbalance condition that is given by VC is equal to that common voltage, VC is equal to V1 plus V2 by 2. The input voltage V1, V2 in terms of VC, we have to write modify that equation now. Yeah. Generally VD is equal to V1 minus V2. V1 minus V2. So V1 is equal to, can I write V1 is equal to VD plus V2. So from this we can written as in terms of V1 in terms of VC and VD we have to write, and V2 also we have to write in terms of VC and VD. From these equations, we have to write both V1 value and V2 value in terms of VC and VD. That is V1 is equal to, we can write like VC plus VD by 2. V1 is equal to VC plus VD by 2. And V2 is equal to VC minus VD by 2. Terminals, input terminal voltage, V1, V2 value in terms of VC and VD. Just simply you can substitute VC value here. You will get this thing. You can cross check. And V2 value you can write, VC value you can substitute here. You will get the same thing. That is thing. That V1 value, V2 value in terms of common voltage, and other one is a differential voltage, VD. That common terminal voltage, VC, that is the average voltage, and differential voltage is a VD. Okay, this is a thing. This VD by 2, it can divide it into two parts. One thing is, if in case of this is connected to the common, these two terminal connected to the common, that can be splitting into two parts. Here only we can adjust the diagram. If in case of these two terminals connected to common, if in case of these two terminal connected to volt, like this, common terminal, we'll get here common voltage VC. This is connected to again ground. Extra thing will be go to ground, another terminals. That VD, the voltage difference between the two terminals. That VD here divided by two terminals. So VD by 2, VD by 2. This is a positive terminal, so plus VD by 2. This is a negative terminal, minus VD by 2. Here gain is a AV, A minus. Here is a plus. Gain thing. Output voltage similarly same. So here next furtherly it won't be that these are feedback things. This is a operation 741 operational amplifier things. From these we have to calculate the formula. That formula also we have to write compulsory in exam. One minute. From these we can calculate output voltage is equal to, in terms of gain, nothing but simply is a gain is equal to output value by input. Here input nothing but is a VC, common thing on. So here output is a simplest value is a plus A minus values in terms of both. So here both the terminals are connected now. So in terms of VC we have to take, in terms of VD also we have to take it. Output voltage is equal to VC into A minus A plus VD into that voltage is A. It can divide it by half only. A minus means A plus A minus, both half. It can divide it by 2. From this you can calculate V0 value. Here V0 value. Instead of that, simple thing is a V0 is equal to output voltage across that thing is a VCAC plus VD AD. Now here, common mode rejection ratio, that is thing in the CMRR. When V1 value, V2 value equal, in that condition, imbalance voltage, that is called as a common mode rejection ratio. That is a difference gain minus by, that is a common gain. That is a VAD by AC. From this you can find out. For example, you can consider the equation numbers. Previous we consider any equations, no, whatever maybe. From this you can calculate V out value. V out value in terms of only D. From this you can calculate AC is equal something. AC is equal to AD by CMRR. This AC value can substitute in above equation. That implies V0 is equal to VC instead of AC. That is a AD by CMRR plus again VD into AD. VD into AD. Okay. Now we can take common here AD. Here AD is there na? Then V0 is equal to AD into VD plus VC by CMRR. AD into VD plus this VC. That is the difference voltage. Okay, right. If in case of here VC nothing but V1 plus V2, that is difference value only, no? That is thing only matter. So enough. This up to here only the conditions. And CMRR, that value, that it can be expressed in terms of decibels. The sound value is a dB, decibels. For ideal operation amplifier, the CMRR is infinite. That value you can write. CMRR in terms of dB, that is equal to 20 log AD by AC. That's it. This much is enough. For that CMRR. Similarly, next one, slew rate. The next furtherly slew rate. The slew rate is a simple thing, is a pulsative changes. That pulsative changing purpose will use that slew rate. So for the input for that operational amplifier, one is terminal is connected to ground. This is pin is connected to ground. Other pin is there na, this directly. For this one, parallelly one capacitor is connected. Parallelly one capacitor is connected. Across this capacitor, voltage we have to calculate. First we have to find out the current across the capacitor thing. That changing purpose will use the capacitors. That capacitor is connected to the input terminal in parallel. I think you know current across the capacitor formula. Generally, I is equal to Q by T. That Q value it can be written as in terms of voltage and capacitance. From the definition of capacitance, lower grades, C is equal to Q by V. From that, Q is equal to CV. So dq is equal to C into dV for dt current. So from that, it can be written as I is equal to C into dV by dt. This is the equation. This equation they gave directly in the textbook. Did you understood? Current across the capacitor, I is equal to C into dV by dt. That derivation like this. Then basically I is equal to current, the rate of flow of charge, Q by T. The rate of flow of charge is called as a current. I is equal to Q by T. So across the capacitor, current is a I is equal to C into dV by dt. From that, you can find out voltage rate. dV by dt, you can something you will get. From that equation only, you can find out dV by dt value. So dV by dt is equal to I by C, current by capacitance value. Based on that, you can get the rate. From this, you can written as dV by dt is equal to I by C. I by C. Based on that, they can get the current. We can measure with the help of here. We can connect the one ammeter. With the help of ammeter, we'll get measure the simply input current value. That current value you can substitute here. The capacitance, how much you are placing that thing. Based on that thing only, we'll get voltage rate dV by dt. So from that only we'll get thing. The graph we can draw the graph between voltage and current. From that only we'll get that slope. That slope it can give the thing only. So here graph between voltage and time function. Time function you can take it as an in terms of second. T in terms of second. Voltage on y-axis in terms of volt. That value. Then we'll get the slope of that thing only I by C. It can go straight and passing to the origin graph nature. That value will it can give dV. This is a dt. That is a dV by dt. It can give I by C. This thing obviously will do in the lab also. Same thing. They can give only formula in the laboratory. You can find out that things. The formula is like this: dV by dt is equal to I by C. That I by C value, that rate of flow of voltage. That is a dV by dt conditions. Just a second. Yeah. From that slope is called as a slew rate. That is simply is a slew rate. For example, they gave in the question, current they gave 60 microampere. Capacitance value they gave 30 picofarad. Then you can find out the slew rate. Nothing but dV by dt. It will be easy only. You can take the ratio calculation only. Understanding? You can go through it. Your textbook page number 142. Textbook page number 142. In that thing only they gave. For example, they gave current value is something value. Na? Current is equal to 60 microampere. And next for the turn capacitance value is 30 picofarad. Okay, the maximum rate of voltage change. They're asking dV by dt is equal to question mark. dV by dt is equal to question mark. Formula here dV by dt is equal to I by C. That I value is a 60 micro, 10 to the power of minus 6. 30 pico. Pico value milli, micro, nano, pico. 30 into 10 to the power of minus 12. You can simplify 31s are 32s are will go up. dV by dt is equal to 2 into 10 to the power of minus 6 into 10 to the power of plus 2. Then we'll get dV by dt is equal to 2 into 10 to the power of 6. That is a volt per second. dV by dt value. So it will be 6 na? Yeah. Right. Like that only. Okay. Here the pulsative and the slew rate it can be using with that voltage applying per second. This value it can changes from one to other thing. The slew rate is defined as the maximum rate of voltage. Underline it. That sentence. The maximum rate of voltage. Sorry. The maximum rate of output voltage change without distortion, meaning without disturbance. That is called as a sinusoidal output is given. That thing is, one thing is converted to other. That pulse you can write compulsory. This pulse compulsory, you can draw this figure. For example, here slope is yes, whatever may be. That value here plus 10 volt minus 10 volt, it will be there. So maximum directly can take like straight line slope. For this one, you can take it as slope. Negative. It is increasing, decreasing. Next decreasing, then increasing. This is converted. So this sine wave converted into a ramp wave or nothing but triangular wave. This conversion purpose will use this thing. Okay. So entire this unit, these three questions are important.
Sir, in examination, how up to right
offset current, common mode rejection ratio, slew rate, they can ask 3 together or else any 2 or else any one in short answers. And one more is characteristics of ideal operation amplifier. And one more thing is a previous one, that is a inverting, non-inverting things only. Entire this unit you can expect hardly one question.
So slew rate we have to write up to definition, sir.
Yeah, up to definition diagram. This diagram compulsory.
Okay.
This diagram compulsory. Okay.
Okay.
Then next one is a second ninth unit. Operational amplifier configuration. This operational amplifier configuration, it is also very, very important examination point of view. That is a inverting configuration, non-inverting configuration. In that inverting, non-inverting compulsory, you can expect one LAQ. The previous unit, you can expect one short answer, but next ninth unit, you can expect one long answer, means 10 mark of question. Either an inverting configuration or non-inverting configuration or compulsory, you can expect one. So here, completely mathematical part only. Okay. Better this mathematical part we can see in the next class. Hardly I have 2 more classes. In these 2 more classes, I'll finish this second block. Means unit 9, 10, 11, 13. Up to 9 to 13, these 5 units. That 5 units I'll finish in next 2 more classes only. Okay. Already I took 8 classes or 7 or 8 classes I took in offline mode. In next 2 classes, I can finish these remaining 4 units, hardly 5 units. Unit number 9, 10, 11, 12, 13. These 5 units I can finish in 2 classes. Is it okay? So next, this 9th block is hardly, it will take 10 to 15 minutes. Then next, furtherly blocks also, it can finish 10th unit also, it can take hardly 10 to 15 minutes only. These are short things only. And this is the 9th block, completely mathematical part, that is a inverting amplifiers, non-inverting and inverting configuration. These 2 configurations say very, very important things. Okay, na? This time up to 4:30 na. So if I start this thing, it's not sufficient to cover in this 10 minutes, this explanation. So better we can continue in the next class. In hardly in the next 2 classes, I can finish unit number 9 to 13. I can divide it into two units are two units, 1 class, 3 units in 1 class. Next class, I can divide into 9, 10, 11, 1 day, then 12, 13, 1 day.
Sir.
Tell me now.
Sir, next Sunday practical classes will be there, no? So this video class, online classes will be there or not?
Madam, I think they posted that theory class timetable in the group. Is there in the,
no,
according to that
classes
time?
Will be start, no sir, from 13 onwards.
13, yes, correct only. But how they plan schedule, I don't know exactly. But I saw previous days. Once you can see in that theory classes timetable.
Yes, sir, but practical classes are starting.
If the practical classes, theory classes coincide, they can stop the theory classes. They can reschedule theory later only.
Means after completion of practical classes only,
yes.
Again it will be, sir?
Yes, sure. That is the correct way.
Okay,
they said
sir,
clearly, they gave dates 0, 1st to 7, 8 to 14. So this 14, 15, not possible to, 14, 15, 21, 22. That last 5-6 days class is not possible to take theory and practical togetherly. So
again,
mostly,
sir, again second spell will be 29th onwards.
Yeah.
Till
better
13th of June.
Yeah, obviously. This time they splitted the practical 2 spells. 13 to 29th, 1 spell, and 1 to 15 or 16 another spell. 2 spells.
From 1st to 16th, sir? No, sir. From 29th to 13th. Second spell.
Exact date I don't know, but they separated 2 spells. Those based on your convent, you can join in first spell or second spell. That is your wish. I think they can give the time to conduct the classes in the evening hours, maybe. I think 10 to 4 practical times.
Sir, practical class is only working days. Puspa madam is posted. No holidays classes in practical.
Yes, correct only.
Only practical exam working days. Maybe Monday to Friday.
No. Practical, even though in holidays also they can conduct. Even the Sunday also, any other day also, they can conduct continuously.
Puspa madam is posted, except holidays, another day will be conduct a practical exam.
But I don't know that thing. But recently she posted practical spells divided into 2 spell, 1 and second spell. First spell they said 13th of May to 29th or 28th of this month. 28th. 29th to June 13th. I don't know exactly. That day they allotted 2 spells. Based on the student convenient time, they can join either first spell or second spell. That choice given to student only.
Madam, because madam was posted practicals will be for 16 days continuously without days.
Yes, correct only. We are also saying that thing only.
Okay.
So, madam, she's asking, I don't know madam name. She's asking in the practical time, how they are conducting theory classes. That is our question.
Okay, okay, sir.
Till now, they didn't given any information to us. They given only timetable, and that based on the timetable only, we have to proceed it. But at that time, you will be in the lab only. Not your means not only all students. Few students in the lab, few students they are taking relax time only. So that time, how they are going to planning the theory class? I'm feeling in the evening hours, maybe they can give the choice. Hardly for myself, for 2 classes is enough. In 2 classes, this paper it can finish. At the same time, along with me, another sir, Bala Subramanyam sir, that is a paper 3. He will also finish the syllabus in hardly 1 classes. Hardly 1 or 2, I don't know exactly. Maybe 1 or 2 classes it can finish both paper 3 and paper 4. Why? Because more than 70% syllabus we finish in the offline mode. In the offline mode, hardly 15 to 20 students they came in the randomly. Randomly 10 to 20 students only came, or nearly 90 students. I don't know strength how much, I don't know in that. So maximum cases, maximum time you can do yourself preparation. If any doubt in that, you can approach to consult faculty. For example, paper 4 myself, paper 3 Balasubramanian sir, paper 2 Ramalakshmi sir, paper 1 some other Amish sir also there. So for that faculties, you can contact directly in WhatsApp or normal caller. Based on their convenient time, you can utilize your way of receiving things. Why? Because you are also employed, they are also employed. So here you are getting the further qualification for that purpose. Based on both the sides convenient time, you can utilize the sources. Why? Because all it won't be present in the offline classes. Even though in online classes, not possible to listen everyone in the same times. So my suggestion is, you are not students. I am feeling you are also one type of professors only. Just qualifications less only. That qualification you are going to improving. So you can go through it yourself. The textbook, and of all subject, textbook is enough. It obviously it won't available any kind of guides or any kind of test papers in that market. Only textbook is enough. Even though correction purpose also, reference book is a textbook. For yourself, for myself, everyone's self is a textbook only, reference book only. So you can refer the textbook. If any concept or any topics doubts, you can go through it, that consult faculty. That's better, my suggestion. And practicals, they only explain and they only conduct exam. So definitely everyone will be pass. If you are attend, you will pass. That marks varying based on your performance, their ideas, you will get different score. But everyone will be pass in the practical. But in theory, you will write something on the paper, then only you will pass. Otherwise, they won't give the pass marks now. But obviously, compared to other 4 subjects, our subject means paper 4 is the easiest than other 3 subjects. Every year, all students are getting more marks in electronics only. It is the easiest paper, but don't neglect in that way. So once you can go through it logically, it will be easy and you'll get better score compared to other subject in my paper. So if you have any doubt furtherly, just you can message me. Based on my convenient time, I'll give the replay and I will explain to you.
Excuse me, sir.
But official classes is 10 classes. In that 10, this is a hardly 8. 2 more classes are there. That 2 more classes officially I will take in the next further days according to schedule.
Excuse me, sir.
Yeah, tell me.
Sir, when is our exam?
Exam after finishing up this practical, maybe they can conduct after 1 month gap or 2 month gap based on that university convenient time. Based on other schedules, based on other branches, arts, some other botany, zoology, based on the all students' syllabus timings, based on their own convenient time only, they can conduct exam.
Last year they conducted on September.
Yeah, but due to this COVID, the schedule is disturbed, sir. So based on there, why? Because here PG first years practicals, second year your senior practicals, based on that theory exam togetherly. First year and second year we have to conduct. So based on their convenient time, along with the all branches based
Uh-huh.
on their free time. In that to be without something that board distractions. Based on their convenience, they can conduct. Hardly 1 month before, 20 days before, they can announce in the website. At the same time, in our groups also, they can post the message.
Okay,
But
sir.
anyhow, before that dates only, you can pre-plan. Pre-plan,
sir.
that's better only. Once you can go through it subject-wise, individual preparation yourself, you can be ready at least 50% of scoring.
Okay,
And
sir.
when they announce the exam dates, that time you can revise. Definitely, will get more than of 70%. Definitely, they can give the high much percent compared to other distance universities. This Ambedkar University, definitely they can give the high percentage. Last time in my subject only, out of 70, one student got 60 marks. Can you believe that thing in distance mode? Out of 70, they got 60. 60, hardly 4 or 5 students, they got 60 marks in one subject. So
Okay.
almost other subjects also will get. So easy scoring purpose subject is this thing. Okay. So in my schedule, next 2 classes, 9, 10, 11, 1 day. 9th unit, 10th unit, 11th unit, 1 day. 12th unit, 13th unit, another last day. That day only I'll give the important questions in that unit wise. One thing you can believe, only one thing is previous question paper you can believe, based on that questions only you can expect next exam. That much only. They are going still, also they are following only previous question paper only. Is enough. Once you can go through it, hardly 3 years back, minimum 3 years back question paper, definitely you will get nearly 45-50 marks.
Sir, 3 years question paper ఎక్కడ దొరుకుతాయి సార్ మార్కెట్ లో దొరకట్లేదు.
Already, no, it won't available in the market. Market is not connected with the BRAOU. PG levels, degree level, okay, but PG is not, does not connected. Only our branch and connectivity students only. That's why they created a group now. In that group only we are posted different kind of question papers. There are different faculties. I already posted that when that group is created, the starting first 2 classes only I posted in the group. Once I can, if possible, I'll try to send. If not possible, you can collect with your that WhatsApp group members.
Sir, can you give me the number, sir?
Yeah.
Can you add?
I think you don't have in that group.
No, sir. No, recently, today only I am listening the classes.
Oh, sorry. So I'll try to send it. Once you can send a message to my WhatsApp number, I'll try to send it.
I don't know your number, sir.
No, my number is 9492.
Sir.
9492304066.
Double?
My name is 66.
Okay.
9492304066. My name is Roger Reddy.
Okay.
I'm working in 3 modes: intermediate, degree, and PG.
Okay.
3 modes I'm working in Hyderabad only.
Okay.
When I'm free, that time only, please, I will give the reply. Instantly, I won't give the reply. If in case of any other classes, anywhere, I'm working 2-3 different locations. Based on my free time only, I will give the reply, please. Okay?
Okay.
If you have any doubts related to our subjects or related to any administration side, if I have idea, I'll give it. Administration purpose, better you can go through it, Usha madam. She will give the 100%. She only take caring of in charging of that our physics block. Na? Our HOD is a Pushpa Chakrapani madam. Next person is a Usha madam. After that, subject faculties we are taking in the one subject individually. In my electronics paper wise, I can help you.
Sir,
Okay. Yeah, tell me.
sir, you posted that question papers, no, sir. In that question papers,
Yeah.
Not repeated questions are not there, sir. Means
No.
different.
Previous, no. The
So how
once
can we guess important questions, sir?
Once you can see continuously 3 papers togetherly.
Yes,
First
sir,
time
I
which
have
question
checked.
is given. The next
Yes,
time
sir.
adjacent question they can give. Same question they won't give. For example, inverting operation amplifier, non-inverting amplifier is there. Inverting is given this time. So you can expect next time and non-inverting.
So I have to read everything, sir.
Yeah. So that's why I was given that finishing up that units instantly. I was given few important questions only.
Sir,
in the classes.
Sir,
For example, today I took only first unit. First day class, that's why I took only first unit. In that unit, offset current, that is offset current, common mode rejection ratio, slew rate, one LAQ. And previous one characteristics of operation amplifier, and first thing is virtual ground. That 2 questions are SAQ, means 5 marker. These 3
Sir.
parts is only enough. 3 questions only is enough, and this unit. No need to learn each and every basic. That understanding purpose you can go through it. But examination point of view, question to answer only is enough.
Sir, one more request. In last class, will you give some important questions, sir, for every unit?
Sure.
Thank you, sir.
Last class I'll get.
Sir,
Yeah.
excuse me, sir.
And tell me, sir.
Sir, once again, can you share that question to WhatsApp group, sir?
Yeah, okay.
Okay, sir.
Already
Thank
that
you,
is
sir.
3-4 times viral in that group only.
Okay.
I'll try to send. Otherwise, just you can give to a message to my number. I'll send to you personally. That's better only now.
Okay, sir. Okay, sir. Thank you, sir.
Okay. Bye. Great. Well, next, based on their communication, it will be there. Next time, that is good question. 13th onwards practicals na. They can update in the WhatsApp. If is there any classes, we can update in the group. Based on that message, WhatsApp group only, you can proceed it.
Okay, sir.
But based on the WhatsApp group message only, timing and everything is we can proceed it. That based on that thing, hardly I can finish in 2 classes my syllabus. Furtherly, if you have any doubts, extra time in the evening hours we can plan. That is our interest. Okay. Bye.
Sir, before that date will come, no, sir. Then only if you give means that is very convenient for us.
Sure.
Thank you, sir.
Okay. Bye. Bye, everyone.
Bye.